The search for life and the James Webb Telescope. As we stare into the infinite expanse of stars, a question has echoed across centuries, whispered in the minds of philosophers, scientists, and dreamers alike. Are we truly alone in the universe? From the earliest civilizations, humans have looked up at the night sky seeking answers. The Babylonians and Egyptians studied the stars for guidance, while thinkers and scholars throughout history imagined other worlds, wondering if life might exist beyond the fragile blue planet we call home. Today, our search has evolved into something extraordinary. Powerful telescopes scan the heavens, capturing light that has traveled for billions of years, offering a glimpse into the distant past of the cosmos. And none of these tools is more remarkable than the James Webb Space Telescope. Launched in 2021, Webb is more than a telescope. It is a time machine, a window into the ancient universe, and a magnifying glass capable of revealing details previously invisible to humanity. Its massive golden mirror, stretching over 6 meters across, collects faint light from distant galaxies, stars, and planets, allowing scientists to explore regions of the cosmos that were once completely hidden. Unlike Hubble, which primarily observes visible light, Webb specializes in the infrared spectrum. This allows it to pierce through thick cosmic dust, revealing the birthplaces of stars, the hidden structures of galaxies, and planets orbiting distant stars, worlds that were once invisible to even the most powerful telescopes. Recently, Webb focused on one such world, K2-12B, an exoplanet orbiting a small, dim red dwarf star about 120 light-years from Earth in the constellation Leo. What makes this planet remarkable is its position within the habitable zone of its star, the region where temperatures might allow liquid water to exist on the surface. Water, as we know, is the foundation of life. Its presence on a distant planet raises profound questions about the potential for life beyond Earth. When scientists first examined K2-12B, they were stunned. Not only did they find signs of water vapor in its atmosphere, but they also detected traces of molecules associated with biological processes on our planet. K2-12B is a type of planet known as a sub-Neptune, a mysterious category larger than Earth but smaller than Neptune, with no equivalent in our solar system. Unlike rocky Earth-like planets or massive gas giants, sub-Neptunes occupy a space in between, leaving many questions unanswered. Are they primarily rocky worlds shrouded in thick atmospheres? Or are they small gas planets with hidden oceans beneath their clouds? The true nature of K2-12B is still a mystery. Its orbit is equally fascinating. K2-12B circles its star at just 0.18 astronomical units, closer than Mercury is to our Sun. A single year on K2-12B lasts only 13 Earth days. Yet despite its proximity to the star, the planet remains within a habitable temperature range, thanks to the dim, cool nature of its red dwarf star. This delicate cosmic balance allows for the possibility that liquid water could exist, even under conditions very different from those on Earth. Webb's instruments detected methane and carbon dioxide, common planetary gases, in K2-12B's atmosphere. But the real surprise came with the potential detection of dimethyl sulfide, DMS, a molecule almost exclusively produced by living organisms on Earth, particularly marine plankton. If this discovery is confirmed, it would mark the first evidence of a biomarker on an exoplanet, a chemical whisper of life drifting across the cosmos, finally captured by human ingenuity. The implications are staggering. For the first time, humanity may have glimpsed signs of life beyond Earth. Yet scientists remain cautious. Natural processes could mimic these signals, and further observations are required to confirm the findings. Even so, K2-12B challenges everything we thought we knew about planetary habitability. Red dwarfs are known for their violent flares, capable of stripping away atmospheres and sterilizing planets. Yet K218b appears to maintain its gases, and perhaps even its oceans, suggesting that life, if it exists there, may be far more resilient than we ever imagined. Hycean worlds and the possibility of life. The discoveries at K218b have introduced a new concept in planetary science: Hycean worlds. These are massive planets with deep global oceans, cloaked in thick hydrogen-rich atmospheres. They can be up to 10 times the mass of Earth, with oceans that make up nearly 90% of their total volume. Beneath these endless waters, life could flourish, even in extreme heat and crushing pressure. Imagine K218b in your mind. A world bathed in the red glow of its star, with skies shrouded in thick, hazy clouds. Beneath those clouds stretches a global ocean deeper and darker than anything on Earth. In these alien waters, microscopic life forms could drift silently, consuming energy and releasing gases into the atmosphere. These gases, tiny chemical fingerprints, could explain the signals Webb has detected across the vast gulf of space. If confirmed, this would be one of the most profound discoveries in human history. Hycean worlds are not rare. In fact, sub-Neptunes are abundant in our galaxy. If these planets can support life, the universe may be teeming with it, and our search for life may need to expand far beyond Earth-like worlds. Webb uncovers these secrets using a technique called transmission spectroscopy. As K218b passes in front of its star, some of the starlight filters through the planet's atmosphere. That light carries a unique chemical fingerprint, which scientists can analyze by splitting it into different wavelengths, like a prism dispersing white light into a rainbow. This technique allows them to detect methane, carbon dioxide, water vapor, and possibly even DMS. But the significance of these findings extends far beyond chemistry. For centuries, humanity has wondered whether we are alone. If K218b truly harbors life, it would mean life is not a rare miracle confined to Earth. It is a natural outcome of planetary evolution, a cosmic phenomenon written into the fabric of the universe. Consider the ripple effects. If a planet just 120 light-years away could host life, then the Milky Way's estimated 100 billion planets may be brimming with it. Civilizations, primitive or advanced, could be thriving beneath alien skies at this very moment. Humanity's understanding of our place in the cosmos would be forever transformed. And this is only the beginning. Webb will continue observing K218b in greater detail. Future missions, like NASA's Habitable Worlds Observatory, may be able to directly image distant exoplanets, revealing oceans, continents, and even seasonal changes. Step by step, we are moving closer to answering the question that has haunted humanity for millennia. Are we alone? So, what do you think? Are we hearing the first whispers of life from a distant ocean world, or are these signals simply natural processes we do not yet understand? Could K218b become the first confirmed inhabited planet beyond Earth? Let your imagination wander, and let your curiosity guide you. And if you enjoyed this journey into the unknown, don't forget to like, share, and subscribe. Because with each new world we discover, the possibility that we are not alone becomes harder and harder to ignore.